So if you're trying to use the direct comparison test, but your inequality goes the wrong way, there are a few options that are open to you. One option is just to choose another comparison series. The comparison series, those a sub n's, those are things that we make up on our own, and we can try and make up a different one. If you can't make up a nice one, we have the limit comparison test. With the limit comparison test, I take the terms of my two series and I divide terms of the same index, and I take the limit as those indices go to infinity. If this limit is 1, well, if you divide two things and get 1, that means they were the same. So if this limit is 1, that means as time goes on, these terms look pretty similar. If this limit is 2, that means one is just twice the other. And if I have twice a series, well, that doesn't affect whether it converges or diverges. If this limit is a positive finite number, that tells us that the series behave similarly, that the terms are sufficiently similar that both series converge or both series diverge. Now, if you get 0 or infinity, actually the limit comparison test is no stronger than the direct comparison test. So let's think about these two series. The top one is a p-series. We can instantly see that it converges. The power is 3/2, and 3/2 is bigger than 1. Here's another series, and we want to know whether we can compare them. The second series has a smaller number in the denominator when n is large, so its terms are bigger overall. This is the case that the direct comparison test can't handle. I know terms of a series have to be small for the series to converge. I know terms of my p-series are small enough that the series converges, but my mystery series is bigger. So the direct comparison test can't tell me whether this series has terms that are small enough to converge, or whether it has terms that are so big it causes the series to diverge. We can, however, use the limit comparison test. Let's name our ANs 1 over n to the 3/2. For limit comparison, it doesn't really matter which one you name A and which one you name B. Our BNs are the other terms, 1 over n to the 3/2 minus n. And I'm going to take the limit as n goes to infinity of my a sub n's divided by my b sub n's. Since I have a fraction over the fraction for the bn's, I flip and multiply. N to the 3/2 is n to the first times n to the 1/2. So my fraction simplifies to 1 minus 1 over the square root of n. As n goes to infinity, this goes to 0, so this limit is 1. 1 is a positive finite number. So what does this tell us? Well, as it tells us as n gets real big, an divided by bn looks like 1, so an looks a lot like bn. So the series do the same thing. So by the limit comparison test, my mystery series converges as well.